Hey, this is Mr. Beckstrom, and I want to take a look at number 73 from section 1.1. And it says, working with difference quotient, simplify the difference quotient f of x minus f of a divided by x minus a for the following function. And they give us the function f of x is equal to negative 4 divided by x squared. So with this, we really have to understand what it means to be f of a and x and a. So x and a are simply just x and a. F of x is defined as this function here of negative 4 over x squared. And let's go ahead and define f of a. So f of a tells us we go to the f function here and we replace any x's with a's. So f of a is simply just going to that f function, and wherever there is an x, we're just going to replace that with an a. So it's simply just negative 4 over a squared. So now we have our f of x to plug into there, we have our f of a to plug into here, and x and a are simply just x and a. So we're going to put everything in, and then we are going to use some math and simplify it and see what we come up with. All right, so f of x is equal to, we're going to replace this up here. That's just negative 4 over x squared. And then we have minus. And I'm going to put the f of a in parentheses because we have to remember to distribute that negative sign. And f of a is negative 4 over, oops, let me go ahead and write that 4 a little bit better, negative 4 over a squared. And this is all divided by x minus a. X minus a. Alright, so then this is going to equal, and I'm going to go ahead and distribute that negative sign. So this is going to be negative 4 over x squared plus 4 over a squared, because a negative times a negative is a positive, all over x minus a. Alright, the next thing I want to do is I want to go ahead and combine these two fractions, which means I need a common denominator. And often when we're dealing with denominators that have variables in them, we're just going to multiply those two denominators together to get that common denominator. So x squared and a squared, if we multiply those two together, we just get x squared times a squared. So that's going to be my common denominator. So to get x squared, a squared on the left, I have to multiply the top and the bottom by a squared. So this left is going to give me, if I multiply the top and the bottom by a squared, it's just going to give me negative 4a squared all over x squared, a squared, x squared, a squared. And that was just multiplying the top and the bottom by a squared because I'm trying to get a common denominator between these two fractions. And plus, I'm doing the same kind of thing over here, except I'm multiply the top and the bottom by x squared. So this is going to be plus 4x squared over x squared, a squared, x squared, a squared. And I still have all over x minus a. Alright. And now I can combine these, the tops of them, because I have a common denominator here. So this is going to be negative 4a squared plus 4x squared. And I'm going to go ahead, since addition is commutative, I can add them in any order. So I'm just going to switch it. I'm going to write it as 4x squared minus 4a squared, because it makes it a little bit nicer there. Instead of negative 4a squared plus 4x squared, I'm going to write it as 4x squared minus 4a squared. You could have done it the other way and changed it later, but I think it's a little bit easier if you see that now. And that's going to be all over x squared, a squared, x squared, a squared. And this all goes over x minus a. And then from here, notice that I have a common factor of 4 on the top there. So I'm going to go ahead and I can pull that 4 out now. So I can pull it out of the entire factor there. So I'm going to call this 4, and I can pull that out of the whole numerator, this whole numerator. So that's going to be, and then what I'm left with is just x squared minus a squared. And notice that that's a difference of squares. That's one thing squared minus something else squared. And the difference of squares can be written as x, or the first thing plus the second thing times the first thing minus the second thing. So this is going to be x plus a, and that's going to be all times x minus a. All right, and then this is all over x squared a squared. And this is all over x minus a. All right. And notice if I were to multiply this back in, this 4 just goes to that numerator there. So I would get this back. So if you're getting confused, make sure that you can do the reverse process. All right, so I'm here. And remember, when I'm dividing with fractions, I can multiply with the reciprocal of the denominator. So this is going to be equal to 4 times x plus a, x minus a, all over x squared a squared. And this is going to be, we're going to multiply this by the reciprocal of x minus a, which is 1 over x minus a, minus a. And notice I have a nice little common factor there, which I can cross out. And I finally get 4, and that's going to be times x plus a all over x squared a squared, x squared a squared. And I think my a's are looking more like 9s. Let me see if I can. There. Well, I don't think that's very much better, but let's try to make it a little bit more like a's. This should be your final answer right here. So if you have any questions, let me know, and I will leave some of these other ones for you to do. I think I tried to pick out the hardest one to show you, and I hope you all have a great rest of your week. Thanks. Bye-bye.